Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have square root of k into square root of k into square root of k plus square root of k equals to 10, and we solve this problem for the values of k. So here the very first step we are going to do is, here first we simplify this equation and we write this equation in simplified form, as because you see here square root of k is multiplied by here 3 times, so we write this term in exponent form. So we write it as square root of k and its whole cubed plus this is square root of k equals to 10. And now in the next step, here we need some simplifications, and now we convert this radical equation into the simple cubic form, so that we just take here the square root of k equals to y. So that here we take y equals to square root of k. So our above equation is written as in this form: y cubed plus y equals to 10. And now in the next step we just solve this cubic equation, and we have several ways to solve these type of cubic equation. So here we just make the factors of this cubic equation by using simple factorization technique. So here first we focus on the right hand side, and we have y cubed plus y equals to, this is 10, and we break this 10 and we write it as 8 plus 2. And now in the next step we write this 8 in the cubic form, and we have y cubed plus y equals to 8, and we write it as 2 to the power of 3 plus 2, because 2 cubed is equals to 8. And now in the next step here we move all the terms from right hand side to the left hand side. So it will be written as y cubed plus y, this is positive 2 cubed. When we move in the left hand side, it will becomes minus 2 cubed, this plus 2 becomes minus 2, and this whole equation equals to 0. And now in the next step here we make the pair of cubic term and the simple terms. So we have the cubic term is y cubed, and the other cubic term is minus 2 cubed, and plus we have this is y minus 2, and this whole equation equals to 0. And now in the next step here we need a nice cubic formula, and you know about this formula: if we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So here we use this cubic formula to the above term. So our above term is written as in this form. So this is y cubed minus 2 cubed, we write it as y minus 2 into this is a square, so our a is y square, and plus ab, so our a is y and b is 2, and b square, so our b is 2 square, and we have the other term is y minus 2, and this whole equation equals to 0. And now in the next step here we need more simplifications, and you see that we have y minus 2 be the common factor, so that here we take common y minus 2, and its remaining terms are y square, and this is 2 times of y, and plus 4. So when you take common y minus 2, here we get plus 1, and this whole equation equals to 0. And now in the next step here we have we convert this case into the two cases, so that our first case is we take y minus 2 equals to 0, and the second case is we take this whole term equals to 0. So here you have y square plus 2y, and this is 4 plus 1 is 5, and this whole equals to 0. So here in the first case you easily get the value of y equals to 2, and here we back substitute the value of y. So in the start of the problem you see here we take our y equals to square root of k, and now we substitute our y is equals to square root of k, and this whole equals to 2. So because we solve this problem for the values of k, So here we take a square on both of the sides, and these 2 and square root are gone, and we get here k equals to 2 square, and our 2 square is equals to 4. So this is the first real root of the given equation, and now in order to find the other roots we need to solve the second case. So in this case, first we find the values of k by using the quadratic formula, and after that we substitute the value of y and we get the other roots of k. Okay, so here first we just write that coefficients of this equation, and its coefficients are a equals to 1, b equals to 2, and c equals to 5. So these are the coefficients of the above equation, and we know that quadratic formula is written as in this form: y equals to minus b plus minus square root of b square minus 4 times of ac, and it is divided by 2 times of a. So this is the our quadratic formula, and now we substitute the values of a, b, and c. So the value of b is minus 2 plus minus square root of b square. So b is 2 square minus 4 times of a is 1, and c is 5, and this whole divided by 2 times of a, and our a is equals to 1. So that here we need some simplification on this quadratic formula, and we will get here y equals to minus 2 plus minus square root of 2 square. So 2 square is 4 minus 4 times of 5 becomes 20, and this whole divided by 2 times of 1 is 2. And now further we need more simplifications here, and we have y equals to minus 2 plus minus square root of 4 minus 20 becomes minus 16, and it is divided by 2. So here we rewrite this square root term as minus 2 plus minus square root of 16 into square root of minus 1, and it is divided by 2. And here we know that the square root of 16 is 4, and the square root of minus 1 is iota, and this whole divided by 2. So here we need to just break this fraction, and we write it as minus 2 over 2 plus minus 4 over 2 iota. So this 2 and 2 are gone, and we get here y equals to minus 1 plus minus, this is 2 times of 2 is 4, and it is 2 iota. Okay, so these are the roots, other complex roots which we get from second case, and here we again back substitute the value of y. So when you substitute the value of y is square root of k, so it is written as square root of k equals to minus 1 plus minus 2 iota. So because we solve this problem for the values of k, so here we take squaring on both of the sides in this way. So when you take squaring, it is written as k equals to minus 1 plus minus 2 iota and its whole square. So this is our final answer of this question. So these are the two complex roots, and we have k equals to 4 be the one real root of the given equation. And this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.